We did some parts of topic 11 and 12. Today we will continue more, inshallah, and we will recall first the ideas what we have done already, and then we will go step by step forward. So this is about thermal properties of matter, and this is about kinetic model of matter, and we did discussion on learning outcome A, B. Okay, then we did here also C. We did D also, right? We also brought the idea how the pressure is it. Have you got this D? And D?
Yes, sir.
Yeah, how the pressure is working, like force per unit area. That part we did it with you. Is it? Can
Yes,
you
sir, we did this.
yeah, remember that one? Let me check. You also check so that we both are sure about it. This is on last Saturday class. Here we did. Yeah, Mahi, I wanted you to send the internal energy part. You you sent us this one. This was really nice. Like this, can you please send us internal energy part? We did this,
Okay,
huh?
sir.
Yeah, this is about distinguishing properties of solids, liquids, and gases. You see, there are seven properties we had. Which one we are different? It is really nice, huh? Mahi, you did great work. Thank you so much.
You're welcome,
And
sir.
yeah, this one we did. It is about heat capacity. This is the last part we did, right?
Yes,
Heat
sir.
capacity. And we discuss about specific heat capacity, but we did not write. So here we have this one, motion of molecules and temperatures. Gas, you see, uh, here. When temperature increases, kinetic energy of the molecules increases. They hit the container wall with greater force, hence pressure increases. If the container is sealed, again the volume increases if the container is open. So this part we did. We will do little bit more over there in learning outcome D, no problem. So here we have this one. We can consider this one is little bit left. We will discuss more. We have idea there, force and pressure, but we will do little bit more. Then now we have here A, B, B heat capacity. We are done. Huh? We also done with the formula of heat capacity. Today we will do specific heat capacity. We will do its formula also, specific heat capacity formula. Okay. First we do specific heat capacity. So here we have all. Today, Alhamdulillah, everyone is present. Monica, welcome. We already welcome all of you except Monica. Monica, you joined little bit late, right? That's why. Yeah. So Monica, can you please tell us? You can remember what we discussed about heat capacity. What is heat capacity? It's written also in your notes. What is heat capacity? Hello, Monica. Are you listening? Monica. Hello. Okay, so who wants to say about heat capacity? I think everyone can say, right?
Sir, can I say?
Yeah, sure.
Um, Sir, the heat energy required to increase the temperature of an object by 1 degree Celsius is called heat capacity of the object.
Okay, great. Yeah. So, what is the formula of heat capacity you got?
Sir, the formula of heat capacity is heat energy required divided by temperature change.
Very good. So, in symbolic form, did you get any formula in symbolic form? Like only
Yes, sir.
letters are there. Yeah, yeah. What's that?
Sir, it's C equals Q divided by
Del theta.
yes, sir, del theta.
Del means small. Okay. Del means the difference between two temperatures. The difference we got, that one is called del. Okay, is it clear now? So in
Yes, sir.
physics, in many places you will get del, and we also use this del in our life. Also, when we studied in physics, we had two friends in Dhaka University. When I was studying there, in our class, we had two Rajivs. Then one Rajiv was taller, another Rajiv was very short. So the smaller one we used to say Del Rajiv. You
Oh,
got it?
okay. Yes, sir. Sir, did he feel sad when you said him?
No, he was enjoying this one. He got proud of it that his name is Del Rajiv. There is application in his life. Okay,
Okay, sir.
he was really enjoying, and everyone was saying Del Rajiv. He was really enjoying it. Okay, so here we have uh, heat capacity, and there is also SI unit of heat capacity. What is that? SI unit of heat capacity?
Sir, SI unit is joules per J
Kel-
by K.
yeah, Joule per Kelvin. So why Kelvin? Because Kelvin is the SI unit of temperature. That's why the SI unit of this heat capacity is Joule per Kelvin. If we think of other units, that is Joule per degree Celsius. Okay, Joule per degree Celsius. Is it okay? Have you got everyone?
Yes, sir. Yes, sir.
So, what about Al Farabi, Lamisa, then Abdita, then Monica, Maria, Maimuna? Have you understood this about heat
Yes, sir.
capacity? Okay, now we are going to discuss specific heat capacity. We had little bit discussion about heat capacity and specific heat capacity also in our last week. So specific heat capacity is related to heat capacity. What is the difference? The difference is when we are dealing with heat capacity, we are thinking about the whole object. Like you are taking like a 5 kg block of wood, and that time it is heat capacity. But if you are saying 1 kg of wood, that time it is specific heat capacity. So anything about 1 kg, then you are dividing the heat capacity with 5, that 5 kg, right? That's why it's becoming specific heat capacity. Is it clear? Hello?
Yes, sir.
Yes, sir.
Okay. Okay, so we are now going to our previous formula we got here. heat capacity, then we will just use the same definition with some addition. Okay, with that one we have here heat capacity. So today you write here, mm, here we go. Specific heat capacity, text, specific specific heat capacity. You write today's date. We are doing this one today. So today is 6th of March. Huh? Specific heat capacity, the heat energy required to increase the temperature of increase the temperature by 1 degree Celsius. The heat energy required to increase the temperature uh, of here you add like the heat energy required to increase the temperature of 1 kg object. 1 kg object. It will be sound good if we add here 1 kg object by 1 degree Celsius. It's called the heat energy required to increase the temperature of 1 kg object by 1 degree Celsius. Uh, someone's ring, right? Mobile is ringing. Huh? It's called specific. It happens, no problem. Specific heat. Just take care so that other people are not disturbed. It's called specific heat capacity. The heat energy required to increase the temperature of 1 kg object by 1 degree Celsius is called specific heat capacity. Okay, so what is the difference between heat capacity and specific heat capacity? You understood, right? Hello.
Yes, sir.
Yeah.
Yes,
What is the difference? The difference there is almost same. There is little bit difference. Can you tell me, please? What is the difference?
Well, heat capacity focuses on the object as a whole, and specific heat capacity focuses on 1 kilogram of the object.
Yes, yes, that is the main thing. Yeah. So only 1 kg, if we are doing it, that is called specific heat capacity. And the whole object, that is like you are taking 1 bucket of water. That will be heat capacity, right? But if you are taking 1 kg of water, that is specific heat capacity, right? You got it?
Yes, sir.
Okay. So this is very clear. Now we are going for the formula, right? Formula will be same, exactly same. Here we write specific, just we'll divide with mass. Specific heat capacity uh, equals heat energy required divided by here we have mass mass of the object. If it is like 20 kg, we'll divide by 20 kg. If it is 10 kg, 50 kg, 50 kg, 2 kg, then 2 kg, we'll divide it. Mass of the object multiplied temperature change, right? Here, change. So we write here clearly this one, very specific. Yeah? Specific heat capacity divided by heat energy required divided by mass of the object multiplied temperature change. And in symbolic form also we'll write before that you finish writing this one, we have previously in symbols, previously we had um, small capital C. For heat capacity we use capital C. For specific heat capacity, as we are dividing with mass and we are getting only 1 kg object, that's why it will be small c. Small c equals heat energy required, same thing, q, then mass, then with this del theta, that del theta I have to write here. There is no alternative, I have to write here. Yeah, sketch here. Del theta, temperature change. Oh, you understand it? Del theta. Yeah. Again I'm writing del theta. Okay, are you seeing del theta?
Yes, sir.
Yes, sir.
Okay, do it please. So please take a snap after we write the unit, then you take we write the unit as well here, SI unit. So SI unit will be SI unit, it will be, you understand it now, right? It's joule per kg, then Kelvin, this way, joule kg, joule per kg Kelvin. And we can write also in degree Celsius this way, other unit, same we have do joules per kg degree Celsius. Okay, please take a snap now. Who is taking?
Sir, I am taking.
Yeah, please do it, Farabi.
Sir, I've submitted.
Yeah, okay. Thank you. Thank you so much. Okay, then now we have here specific heat capacity formula unit. We can do numerical questions on it, right? We have lots of numerical examples on specific heat capacity. I'm showing you some from the worksheet. I will now give upload of worksheet. Yeah, here we go. I can remove it, right? Yeah, we had here. Yeah, worksheet, worksheet on topic 11 and 12. Every year, you will get the question on this specific heat capacity, either in MCQ or in structure. It will come. This is the most important thing here. It's a big worksheet because two topics together. It's a big worksheet. You will have lots of examples, lots of practice here. Here is one. Question number 5. Yeah, question number 5. Yeah, Maimona. Hello, Maimona. Maimona,
Yes, sir.
could you please read question 5, MCQ 5?
Sir, my screen is very blurry. I can't really see properly.
Okay, okay.
Question number 5, sir.
Yeah, yeah. Yeah, are you seeing now?
Yes, sir.
Okay, okay. Read,
The
please.
specific heat capacity of lead is 130 joules per kg. Lead of mass 0.50 kg is heated from 10 degrees Celsius to 35 degrees Celsius. Which calculation gives the amount of thermal energy in joules absorbed by the lead?
Yeah. So, which calculation gives the amount of thermal energies? That means they are asking you about the thermal energy absorbed by the lead. So, heat energy required. We can rearrange the formula, right? Q equals mc del theta, right? We can write isn't it? Hello, we got the formula C equals Q by M del theta, isn't it? Please
Yes, sir.
respond, everyone. So here
Yes, sir.
the specific heat capacity is given. We are going to find heat energy required, so we can write Q equals mc del theta. If we rearrange, so which one will be our answer here? Q equals mc del theta. Is it A or B?
A, sir.
A. Why A? Because del theta is here 25, right?
Yes, sir.
Here del theta is 25. That's why. Oh,
Sir, I don't understand
yeah.
how is it 25?
Because they say um, lead of mass 0.50 kg is heated from 10 degrees Celsius to 35 degrees Celsius. So del theta is the temperature change. And then 35 minus 10 degree Celsius, it is making 25. Got it, Mahi? You got it?
Yes, sir, I got it now.
So everyone got it? So the answer will be A here. So it is the application of the formula just now you learned. We can have another discussion, another one. This is also related to, you know, one of the formulas we are going to discuss. That is specific latent heat. We will go to discuss, and then we have here, here another one, 11. Yeah, Adrita, can you read this one, 11?
Yes, sir. The temperature of a 50-gram mass of metal is raised by 40 degrees. The specific heat capacity is 0.40 J per gram degree Celsius. How much thermal energy is supplied?
Yeah. So when we read, we say joules. We write J, but we read joules.
Okay.
0.40 joules per gram degree Celsius. Okay. Then you identify first the formula. What is the formula? It is about thermal energy supplied, right? So what should be the formula?
Um, MC del theta.
MC del theta. Great. So it's now MC del theta. Which one is M?
50 grams.
50 grams. Then you have C given, right?
Yes, sir.
Specific heat capacity, that is zero point 0.4, and you are given also del theta. They said already raised by. Raised by means what is increased, what is changed, and that one is given 40 degrees Celsius. So del theta is here 40 degrees Celsius. Then what should be the answer? Check. Everyone check and get the answer.
Sir, I got D.
Yes, you got D. I also got D. So everyone got D, right? If you just
Yes, sir, I
multiply
got
all of
D
them,
too.
yeah, everyone you will get D because it's simple. Only you have to multiply all these three. That's it. So this way, in this worksheet already I uploaded. You have a try, huh? Already
Okay.
you got some ideas, so you can try some of the questions from you. Get it printed and keep on trying. Yeah, like this one here 20 also related to specific heat capacity. Okay, so you have a try. We have also this one, 23, is related to specific. If you look on the question, then you'll understand which one is related to specific. Now you are already equipped with the formula applications. You can understand it now. And also in the structured part, we have some questions related to specific heat capacity. You see here, thermal energy increase, specific heat capacity is there. This one. Okay, you come back. Come back at 7:30. Okay, all of you.
Yes, sir.
Thank you.
Okay,
Some
sir.
time.